A weather balloon has a volume of 750 liters when filled with helium at 8 degrees Celsius at a pressure of 380 torr. What is the final volume in liters of the balloon when the pressure is 0.20 atmospheres, the temperature is negative 45 degrees Celsius, and N, which is number of moles, does not change? So there's a lot going on in this problem. You're given a whole lot of different measurements, and when you see a whole lot of measurements like this for a gas, it should kind of signal that we're either thinking about the combined gas law or the ideal gas law. Those are the two equations that relate pressure, volume, temperature, and sometimes moles together. Okay. The difference being, here we're seeing a change. So we're starting with a volume of this, a temperature of that, and a pressure of that, and it's changing, right, to a new pressure and a new temperature, and we're wondering what's the new volume. When you see a change in conditions, that should signal that you're thinking about the combined gas law. Okay, then we're thinking about combined gas law, which is P1 V1 over T1 is equal to P2 V2 over T2. Remembering that all the things with the little 1 means before, all the stuff with the little 2 means after, right? So to solve this, we need to identify what 5 out of 6 of these are, and we'll solve for the 6th one that we don't know. So let's go through the question and try to pick out what all of these different pieces of information are. So what's the initial pressure? Let's see. It's initially got all these conditions. Here's the initial pressure right here, 380 torr. That's P1. What's initial volume? Right here, 750 liters. There's our V1. What's our T1, initial temperature? That's this number here, 8 degrees Celsius. How about the pressure after the change? Here it is. New pressure is 0.20, so that's P2. What's the new volume? Well, that's what the question is asking. What is the final volume, says the question. So we don't know that, right? That's our unknown. And then what's our T2? Our T2 is right here. Temperature afterwards. Okay? You may find it useful to go through the question, literally circle and label what's what, or you can create a list, whatever you're most comfortable with. Once we've got this, we want to start to fit this all into our equation, but one thing you're going to remember is that we need to make sure units are going to cancel. And if we're using temperature, we also need to remember that that needs to be in Kelvin when we're thinking about gases. So we've got some work to do before we can just solve this. We've got two temperatures in Celsius. Those need to be converted to Kelvin. And we also see that our P1 and our P2 have different units of pressure. So we need to change one so that they both match. Okay, so we got a little bit of work to do before we can actually end up solving this. I'm going to make a list here that says conversions where we can do that stuff. Okay, so let's first convert T1 from Celsius to Kelvin. T1 is 8 degrees Celsius. If I add 273, I get 281, and now we're in units of Kelvin. Our T2 is negative 45 degrees C. Add 273, and now we have 228 kelvins. Our temperatures are converted, and we're going to use these numbers now in our calculation. I chose to convert P1 into the same units as P2 because I like the units of atmospheres. You could do it the other way around. You just have to make sure they're the same units. So for P1, that is equal to 380 torr. I can change the units by multiplying it by a conversion factor, which I can look up, right? You can look up how many torr are equal to how many atmospheres. And what you'll find is that there's 760 torr in one atmosphere. Okay, this will cancel our torr. It will be left in units of atmosphere. What you find going through this is you actually get 0.50 atmospheres as our pressure for P1. Now we're ready to plug. Our units are all going to work out, and we can get our final answer. So let's plug it all in. P1, 0.50 atmospheres. V1, where is that? 750 liters. Over T1, which is 281 Kelvin, is equal to P2, 0.20 atmospheres. We don't know V2, so I'm going to leave it as V2. And T2 is 228 Kelvin. Okay. We can rearrange this and solve for V2. So I'm going to multiply both sides by this to move it into the top. I'm going to divide both sides by this to move it into the bottom. Okay, so that will look like this here. Oops, 228 Kelvin. Okay. You can see now how units are going to cancel and give us units of volume. I've got atmospheres divided by atmospheres. That's going to cancel. Liters isn't divided by anything, so that's going to stay. And Kelvin is divided by Kelvin, so those are going to cancel. I can plug this whole thing through my calculator to spit out a number, and what I'm going to get is 1,520 liters. And that's equal to V2, and that's going to be our final answer.